Hi, my name is Clint Wyckoff, and I'm an enterprise support manager here at AWS. And welcome to AWS Supports You, where we share troubleshooting tips and best practices from AWS Support. Joining me today is Ashwini Mohan and Rob Higurita from AWS Support. Can you give us a quick introduction, Ashwini and Rob?
Hi, I'm Ashwini Mohan, Technical Account Manager at AWS. I'm based in Austin, Texas, and I'm one of the Route 53 subject matter expert.
Hi, everyone. My name is Rob Higurita, and I'm a Principal Technical Account Manager located in Austin, Texas as well. And I deal with customers, helping them to improve resiliency in their architecture and using best practices in AWS. So happy to be here today to help.
Perfect. Thanks, Ashwini and Rob. So folks, to the viewers online, thanks for joining the stream. We really appreciate you taking a few minutes out of your busy day. Today, we're going to be introducing you to some ways that you can increase the reliability of your environment with native features that are built into Route 53 on the AWS platform. But before we get into the details today, a quick note to the viewers online. And the attendees here today, please feel free to use the chat window on the right-hand side of your screen. Ask your questions there. And also, please tell us where you're joining us from today. We definitely want to hear from you. Share your thoughts, questions. We'll be answering those live here. So, Rob, hey, can you give us a quick rundown of what we're going to be talking about today?
Absolutely. Thanks, Clint. So we're going to be talking about how to increase reliability in your architectures using Route 53. But before we get started into some of the details, I'm going to let Ashwini dive into some of those intricacies since she's our SME today. I want to give a little brief introduction on what Route 53 is in case you're new to AWS and you haven't used the service before. So Route 53 is our DNS service that's going to allow you to host and register domain names in AWS. So you'll be able to register new domains, and then you'll be able to have public and private hosted as zones within Route 53 that you can use for your infrastructure, from your public-facing websites to your internal DNS for applications that you may build in AWS. We also have additional capabilities to Route 53, such as Route 53 resolvers, which will help you to integrate with your on-premise DNS environments, creating those inbound, outbound resolvers that you can kind of create a hybrid infrastructure using your DNS and AWS with your on-premise environment and vice versa. And then we have a multitude of different record types for various use cases that we're going to kind of cover more in depth as we get going here today, specifically focusing on a couple that will really help with the resiliency in your architecture, but we do have quite a few. So before we get into that, I'm going to go forward here and move into talking about kind of the infrastructure of Route 53 and a little bit about anycast here that we use. So Route 53 is our highly available DNS service. The data plane size has a 100% uptime reliability on it, and it's done so via this kind of worldwide distributed architecture of data plane, essentially items that make it that 100% uptime. So we have here a variety of DNS servers or infrastructure that are routed around the world, as you can see. And we do this in high availability using anycast as a service. So if you're familiar with Amazon's global accelerator, it uses a similar technology called anycast to be able to use, as you can see here, these same IP addresses across the world. So when there might be an issue, say in Sydney or something with traffic there, it's going to kind of be able to reconverge, be able to still route you to the nearest location for DNS and be able to implement and use this. And so you have these different resolvers that will be located throughout the different areas. So as your infrastructure targets Route 53 for these, you're going to have a very resilient availability for DNS. And we do that locally in each side, if we move forward a little bit, into shuffle sharding, which we talked about previously on an episode where we met with one of the well-architected SAs, and he covered in-depth shuffle sharding. So we'll actually drop a link into the chat as well to that episode in case you want to go back and check it out. But shuffle sharding essentially allows you to deploy into multiple availability zones within a region and will help you balance your workload and such there. And so it's a really great episode to check out, just not only for what we're talking about today, how it's implemented in Route 53, but how you can implement it in your own environment to increase resiliency just within your AWS usage. So I'm going to turn it over here to Ashwini to kind of cover our next section. But before we do so, Clint, just wanted to check and see if there are any questions from the audience.
Thanks, Rob. We did have a question from Robert Tables come in. So I'm going to read it here, and it says, due to restrictions on Apex records, if you were to do multi-account domain name delegation, would you put the Apex in your prod account or something else?
Ashwini, I don't know if you want to take that one for Apex records. Yeah.
Sure. So for the Apex domain, it's pretty much if you're doing a multi-domain delegation, you can make use of a prod account. That's totally okay. If I'm not sure if there is any restriction you're facing with that, but yeah, you can totally do the delegation in your Apex domain in your prod account.
Perfect. That was the only question that has come across so far.
Thanks, Clint. Thanks, Rob. Here, I'm going to talk about the Route 53 routing policies. So Route 53 offers 7 basic routing policy, and we will get into details here. So the first one is like a simple routing policy. So that's the default routing policy where customer can point a domain name to a resource using any of the supported Route 53 record type. So the main use of the simple routing policy is like when you use for a single resources that performs a given function for your domain. For example, a web server that serves content for your example.com domain. And next in our list is the weighted routing policy. In traditional round robin, if there are 3 records over a period of a time, every record will be returned 1/3 of the time. However, the weighted routing policy allows customer to assign weights that corresponds to the amount of traffic that should be routed to a specific IP address. And basically, the weighted routing policy is used to route traffic to a multiple resources in proportion that you specify. And the next is the geolocation routing policy. With the name, the geolocation routing lets you to choose the resources that serves your traffic based on the geographic location of your user, meaning that the location that DNS query originates from. For example, you might want all the queries from Europe to be routed to the load balancer in Frankfurt region. So that's where you use the geolocation routing policy. And the next one is the geo proximity routing policy, which provides more control over the geolocation routing policy. The reason is this geo proximity routing lets the Route 53 traffic to your resources based on the geographic location of your user and your resources. You can also optionally choose to route more traffic or less traffic to a given resource by specifying a value that we call as a bias value. And the next one is the latency routing policy. When Route 53 receives a DNS query for your domain or a subdomain, it determines which AWS region you have created the latency record for and determines which region gives the user the lowest latency and then selects the latency record for that region. So the Route 53, like what is the use case here? So you use the latency based routing when you have resources in multiple AWS region and you want to route traffic to the region that provides the best latency with very less round trip time. And the another scenario is like if your application is hosted in a multiple AWS region, you can obviously improve your performance for your user by serving their requests from AWS region that provides the lowest latency. And the next one is our failover routing policy, which is like a commonly used one, which lets customer to route traffic to our resources when the resources is healthy or to a different resource when the first, that is your primary resource is unhealthy. Both primary and secondary can point to anything from Amazon S3 bucket that is configure your basic website to a complex tree of record. So the failover routing policy use cases like when you want to configure active passive failover. The last one which we have in our list is the multi-value answer routing policy. So to route traffic approximately randomly to multiple resources, the customer can create one multi-value answer resource for each of your record set and optionally associate a Route 53 health check with each of your record. And Amazon Route 53 will respond to your DNS query with up to 8 healthy record and gives a different answer to different DNS resolver. So we will look into the example architectures of multi-value and the failover and some of the demo in next section. And before I move forward, is there any question, Clint?
Hey, Ashwini, it wasn't necessarily a question, but something that I think is a good takeaway for the viewers and something we could highlight is the difference or when you would use failover routing policy versus weighted routing policy and maybe some typical use cases there.
For the weighted routing policy, the typical use cases like the blue-green deployment, where you want to slowly, steadily increase your traffic from one resource to another resource. Like you can move from 0 to 100 for one resource and just drop down from 100 to 0 for the other resource. That's where the typical use cases for the weighted routing policy. For the failover routing policy, which I mentioned before, it's like an active passive. So you can have an active resource to be resolved whenever it's healthy. That we call as a primary record set, like something like a website which is working throughout the day, and then you want to resolve to that particular load balancer or anything, any of your website. And if there is any maintenance going on, you want to point it to your S3 bucket, which is like a maintenance page. That's where you can make use of the failover routing policy.
Perfect. There was also a question there about sharding from NOD 143 that I'll answer in the chat there. So I will address that one. So that okay to continue along now.
Thank you, Glenn. Moving forward, so before we get into the failover architecture, I want to quickly provide some more insight about the health check with Route 53. So the health check that monitors an endpoint. So you can configure a health check that monitors an endpoint that you specify either by IP address or a domain name. But at a regular interval that you specify, the Route 53 will submit an automatic request over the internet to your application or your resource or your server to verify whether it's reachable, available, and it's functional. Optionally, you can also configure the health check to make requests to those the user actually make. For example, like trying to access particular URL from your website. So how does Route 53 works here? So Route 53 will periodically check the health of the endpoint that is specified in your health check. It doesn't actually perform the health check when the actual DNS query arrives. And what is happening behind the scene is Route 53 has health checkers in multiple locations around the world. When you create a health check that monitors an endpoint, the health checker starts to send requests to an endpoint that you specify to determine whether the endpoint is healthy. You can choose which location you want Route 53 use, and also you can specify the interval between the checks, like every 10 seconds or every 30 seconds. And each health check, Route 53 health checkers, propagate the results of its health checks to the Route 53 DNS server, which is located worldwide. And each health checker aggregates and analyzes the data to decide the health check status. And one thing to note here is the Route 53 health checker in different data center don't coordinate with each other. So you will see sometimes there are several requests per second, regardless of the interval you mention or you configure in your health check configuration, followed by like a few seconds with no health check at all. And how does Route 53 determine if the endpoint is healthy or not? So it has some threshold. So let me provide you that. So the Route 53 will aggregate the data from the health checkers and determine the input is healthy only if more than 18% of the health checker report that an endpoint is healthy, then Route 53 will consider it as unhealthy. If 18% of the health checker or fewer reports that the endpoint is healthy, then Route 53 will consider as unhealthy. So this is about the health check. Let me quickly move to the architectural discussion. So here is the example of the failover architecture. When a user is trying to resolve the domain name of a failover architecture, if the health check of the US East load balancer is healthy, the Route 53 will resolve to the East load balancer. If the resource in East region becomes unhealthy, uh, um, Route 53 health checker, like my resource health check, will change to unhealthy status, and the Route 53 will automatically resolve to the US West load balancer. Consider if both the primary and the secondary resources are unhealthy, by default, the primary record will be resolved. So that is the basic behavior of the failover architecture. But with complex routing architecture, we can achieve high availability, which we can see in next section. We'll move to the next architecture, which is like a multi-value record architecture. I provided a basic information for the multi-value, but the basic use case is like when the customer wants to create more than one record of the same name and type and routing traffic to multiple resources and associating and health check to the records, that's where the multi-value answer routing policy come into picture. In this example, the Route 53 will resolve to both the IP address, which is 1.2.3.4 and 1.2.4.3. To both IP addresses, provided the health check of both is healthy. If 1.2.3.4 becomes unhealthy over here, the health check status will change to unhealthy status, and the Route 53 will only resolve to 1.2.4.3. So one quick note about the multi-value answer routing policy is like it distributes the DNS response across multiple IP addresses. If a web server become unavailable after a DNS resolver caches it, the client can try up to 8 other IP addresses from the response to avoid the downtime. And the multi-value answer routing is not actually a load balancer. It's not a substitute for a load balancer. The reason is like the Route 53 will randomly select any 8 records. When you perform a DNS resolution for your domain name for a multiple times, you might notice that the IP address keep on rotating. So this rotation will improve the availability and provide some load balancing functionality, and it's responsible for your operating system to perform this round robin DNS for the cached responses, like not the Route 53 will rotate it from your application. Next, we have a demo session. I'm going to hand over to Rob here.
Hey, thanks, Ashwini. Appreciate that. So yeah, we're going to go ahead and jump into the console and into the page to take a look at actually implementing this and doing the Route 53 failover infrastructure here. So go ahead and pull up here. And one of the things we want to cover first is actually just the implementation, right? So Ashwini mentioned a lot about the health checks and how you're going to configure these DNS health checks and how you're going to use these in order to understand which resource is healthy and which resource is unhealthy so that you can have your failover mechanism in place. This is really important to get established and set up ahead of time before an actual event happens. And so you're going to start by taking a look at this Route 53 health checks and configuring DNS failover documentation page. And it's going to be able to give you all this kind of information on how you're going to set up these and cover some other items for our Route 53 checks. So as we get going in here, I have a demo infrastructure very similar to the one that Ashwini was showing on the slides itself, where we're going to have a Route 53, what I call Route 53 ALB East and a ALB in West. So we're going to have a multi-region deployment that we're going to be using in order to implement failover between the two. So you can see I have my one in East, and if I switch over to the West region here, or US West 2 to be specific, we'll see Route 53 ALB West. And that is my two different load balancers that I have in front of some EC2 instances. So we can see here that I have Route 53 US East 1, which is my EC2 instances, or my single EC2 instance in this case, behind my load balancer that is going to be serving my website here. And then if I switch over to the US West side, I have a very similar named instance, Route 53 US West 2, that is serving my website. Just get rid of that error message from the other one. We can see that I just have two instances across the different regions with the load balancer in front of them that are going to be my highly available infrastructure, essentially, in case of a failover. Now, to get all this working so that it actually automatically fails over and I don't have to actually go through and do this myself, right? So I have my infrastructure set up with my US East server here and my US West server. And this is kind of a key element that you want to make sure that you have in place. When you have these infrastructures in two different regions, one thing you really want to do is make sure that you have these failover records set in place, that you don't have to manually go in and make an implementation change during an event, and that it will actually do it for you. So my primary that I have set up, as we saw before, Ashwini was mentioning, we have between our primary and our secondary, and we'll see what that looks like in Route 53 itself in the console. My primary is my US East server. So as we come to my website here, we can see that it's US East server. And if I refresh this page, it's still going to be US East server when I refresh, because it's a healthy record and it's going to direct traffic to that, and not do, like she mentioned before, the multi-value it could return either. So let's switch into my Route 53 console here. And we'll see that I have some different health checks implemented here. And these health checks are going to be what's used to evaluate and understand what is healthy within my environment. So I'm going to be looking at my Route 53 East, and I have my load balancer is my target for this health check. And then I also have a Route 53 West one as well that is doing the same thing. But for East, it sees that we have healthy right now. And if I go over into my actual DNS configuration here, I'm going to go into, I need to actually click into my hosted zone first. I'm going to filter down to just my www records because that's the name of the records that I'm using here for the site. And I see that I have it www.robpig.myinstance.com, and I have a failover record set that's primary and secondary. So let's go ahead and take a quick look at the actual DNS record itself and see how I have this configured. So I'm going to click on Edit Record, and we can see that it's www.robpig.myinstance.com, and then we have this CNAME routes traffic to an AWS domain. Normally, I would say we'd have this alias record checked. In this instance, I did delegate my DNS zone to my other account, so it's going across account DNS resolution. So if I were to click this, I wouldn't be able to choose my load balancer. So right now I have this unchecked, but if you're going to be using this in AWS with your Route 53, we highly recommend you use alias records as well. As we can see here, though, I have got the Route 53 AOB East in this record entry. And so that's my first record set that I have in place for things. And that's what we're going to be using to direct traffic to a majority of the time until this becomes unhealthy. So I've set this record up with a fairly low TTL so that it expires quickly. You can see that my routing policy is failover. And then I have a few other items. And as Ashwini mentioned before, we've got some options here. So we can see simple, weighted, geolocation, latency, and failover. For today's demo, I've got them implemented as a failover. This is my primary record. You're always going to have a primary and then a secondary. And so we can see East again, like I mentioned before, primary. And then we have those health checks designated below to make sure that when Route 53 gets an unhealthy check from my East server, it's going to know to move traffic over to US West. And then, of course, we've got a record ID here below as well. And this record ID is a unique ID that you're going to give to this record set. So I have it just named East LB for this one. And then we'll see here in a little bit for my West one, it's kind of named a little different. All right, so let's take a look at the secondary configuration. See, it looks very much the same, except for now I have West. It's my failover record, as we can see again, but it's the secondary for my failover record. And so we're going to be using that to also have another health check that's checking the resources in West to make sure that we can resolve things to West, and I just have the West LB as my set. So what we're going to want to do is test this and see how this works for us to implement a failover. So we're going to be going into my EC2 instance in US East 1 and being, causing essentially an event there so that we have this failover from US East server to my US West server. So I'm just running Linux and Apache on these servers. So what I'm going to end up doing is going into my EC2 instance and stopping Apache and make sure that it implements and uses the US West side then instead. So if I switch back to where I have my infrastructure located at my other account, we're going to go over to my EC2 instances. In US East, as we can see, I'm on the Route 53 US East server, and I'm going to connect to this. This is my quick plug for Systems Manager, Session Manager. If you're not using this on your EC2 instances right now, it's a big help in being able to connect to your instances without having to open, like say, port 22 to your site or to your corporate VPN or something like that as well. You can actually get to your EC2 instances through the browser or through the AWS CLI, as long as you've got a IAM credentials that allow you access to connect to EC2 instances. So I'll show you real quickly here. I'm just going to connect into my instance, and it's just going to load right here in my browser. Well, it has nothing to do with Route 53. It's still a really nice feature, so I just want to call it out. And I'm going to stop HTTPD, or my Apache service, on my US East server. And we'll stop here in just a second. And now I'm just going to show you the status of it to show that it's actually stopped. And we'll see here that it's inactive, dead, right? And it's no longer there. And if I click refresh, I will get a 502 bad gateway. That's because, as we have to go back in here and check to see, we have those health checks that are occurring on my Route 53 records, and it's going to end up having to become an unhealthy check. And then when unhealthy check happens is when it's going to then redirect target traffic over to my US West servers. So let's go quickly take a look at my Route 53 health check. And we'll see that the whole entire time I've had this Route 53 health check up, it has been going through and checking and coming out as a status of 1, just meaning basically that there hasn't been any overall issues. So eventually we'll see here, and I'll come back to this in a little bit to show you when that drops off. But basically what's happening in the background right now is these health checkers that Ashwini was mentioning before are going through and they are checking against this health check that I have out there to show whether they are healthy or not. And so if we actually go into these health checkers, we can actually see the individual health checkers and the status that they have So again, that kind of evaluative that Ashwini's mentioning of the 18% failure, successful would show. So right here, we can see that all of them are failing because I've stopped that. And if I refresh, I now have an unhealthy health check. And we can see on this page between the different health checks in Tokyo, Singapore, Sydney, Ireland, all over have failed that health check. And it's no longer working there, right? So now we've got a failure condition on my health check, and Route 53 is going to say I'm no longer redirecting traffic to my US East load balancer, and I'm going to start directing traffic to my US West load balancer based on the fact that all of my health checks have essentially failed. But my Route 53 West is still healthy. So again, back to what Ashwini mentioned before, if they were both unhealthy, it would continue to try and send it to Route 53 East. But since I have a healthy health check on my Route 53 West, and I see here that we have that. So because of the fact that it is my secondary record and it's using that health check in here, so we'll bounce back in and I'll just show you since we kind of went through it quickly before. On this secondary, we go back and we edit this record and we scroll down for this, we can see that we've got that failover and it's the secondary one and it's using that Route 53 health check that is still checking through as healthy. And that means that we're going to get traffic to this load balancer instead of my other one. So when I go back to my website and I refresh, I'm now on my US West server instead of my US East server. And I've essentially, without having to actually make changes to Route 53 or really do anything in my environment other than wait for that health check to come through, it has switched my infrastructure over from the US East 1 region to the US West 2 region without me having to make any manual changes, just relying on the Route 53 health checks. I'm going to stop right there really quickly, Quint, just to see if any questions came in from the audience while I was going through the first part of failover, and then continue on just a little bit more.
Yeah, so hey, Rob, there has been a few questions that have come in there. The first one, we did address the shuffle sharding question from earlier. A question from DW Bloodsoe had came in. If you're whitelisting IPs, is there a cap on how many you can do? But I'm not sure if they have seen the chat. I did have a follow-up there. Maybe you could be a little bit more specific as to what you were looking for there in whitelisting IPs and let us know. We'll address that question as we go along here. There was also another one that I think relates directly to what you were showing there in the demo about how, where'd it go? Sorry, trying to scroll here from JibJab. When you're talking about Route 53 health checks, how would these work in conjunction with ALB health checks?
Yeah, I can let Ashwini cover that one because I know she's going to be covering it here a little bit as well on our slides. So I'll let her give her a quick answer on that one.
Sure. So the ALB performs like the ALB health checks. When we talk about the ALB health checks, it will check the health of your EC2 instance or whatever resources that's behind your load balancer. But Route 53 will check the like when you have a like load balancer with Route 53, we always recommend you to make use of evaluate target health. That is something like Route 53 offers. It's one of the feature which I'll be covering in next section. So make use of evaluate targeted so that Route 53 will make all the background work of checking whether the load balancer and the resources behind the load balancer are healthy, instead of you manually creating the health checks for the resources which is sitting in a private one. So health check works only for the public endpoint. So the load like resources which is behind the load balancer will 90% it will be a private resources. That's where we will be using the evaluate target health. I'll be discussing more in next slide.
Awesome. Also, one thing that I wanted to call out there, Rob, that you had mentioned is the use of alias records. That's definitely a best practice whenever you're pointing at AWS specific resources.
Yeah, for sure.
There was another question that has come across here from Seco1604 in what I guess the way that I'm understanding the question that you were asking there is the difference between Route 53 and CloudFront, which I think we can have an interesting discussion here for a minute or two about. So Route 53, as we've been talking about, is a fully featured DNS domain name service that's native to AWS, right? So Route 53, or excuse me, CloudFront being a content distribution network. You know, Rob and Ashwini, how does CloudFront leverage Route 53 and how it delivers content to users? I think that might be a way to help clarify the question.
Yeah, so it's definitely, I mean, in comparison to the two of them, they're kind of used for two different things, right? So CloudFront's kind of to put edge content closer to users to improve performance of static assets like images, it's video content and such like that you can stream through CloudFront. But really designed to have those geographical edge locations closer to your end users to improve performance, where Route 53 isn't really like a performance enhancement so much as it can be used for slightly can be used for performance, right? Because as Srini mentioned, we have the geoproximity, geolocation, latency-based type records that will direct you to your resources closest to your end user based on the Route 53 record type in use. But more so, it's designed kind of to help you with the resiliency as well, or just standard DNS usage in AWS. And Srini, if you have anything else you want to add on to that.
Yeah,
Well,
just one point to add on here is like as Rob mentioned, like the CloudFront is like a CDN and the Route 53 is a DNS. You can use Route 53 to point your custom domain name to your CloudFront because like with AWS CloudFront, we provide a domain name that's not like a user friendly. So you can have a custom domain name in front of your CloudFront and then point it to you. And you can have like a failover as well. Like something goes wrong with your endpoint, like a load balancer or S3,
Mhm.
you can have like a maintenance page, something like that with Route 53. That's where Route 53 you can combine Route 53 and CF together for sure.
Yep. Perfect. So that's all for the questions for now.
Okay. Great. So I'm going to go through here. So we just looked at what it is to implement a failover record really quickly. I'm not going to go through a full failover or anything on this one so much, but just really wanted to show a quick example overall if we were to use a multi-value answer for our Route 53 record type. And so we can kind of do the same implementation that we had. We've got the same infrastructure in US East and in US West, and be able to use a multi-value answer to actually distribute the traffic between the two of them. So right now I have stopped the EC2 or the HTTP service on my EC2 instance. And so that's why we're going to US West right now. But we have the health checks that we can use with our overall instances. As we can see here, I mentioned before, I was going to come back and show you that the health checks actually dropped off. And so that's still unhealthy. So in order for us to test our multi-value answer, we'll have to restart that overall service on the instance so that we actually get a working web page again from US East. So I'm going to use Session Manager again to quickly jump into that server and restart my HTTPD service on it so that we can use this as well in our multi-valued answer, because otherwise it's going to be unhealthy. We'll do a status check again to show you that it's back active and running, no longer inactive and dead on this one. So now if we switch back into our Route 53, since we have a running service in both US East and US West too, we're actually able to now take advantage of our multi-value record. We'll see also our health check will come back to healthy here. So if I switch back, it'll take a few seconds, of course, again, like it did before for it to come. I'm healthy. But if we refresh here a little bit, it might take a second before it's going to come back up. So I'll make you wait for that. But we can go in and we can take a look at a multi-valued answer setup. So I have same thing, just now I've got it www.robpeg.myinstance.com that I'm using for this example here. As we can see, that is a multi-valued answer record. So we'll quickly take a look here. Configuration is going to be very similar to our failover, except we have a public resource that we're going to be pointing to in here where I just have an EC2 instance in each region that I'm going to be using to coordinate this. So I have my instance here configured as my primary in a multi-value. Again, I have my TTL set low and stuff. We'll click into this and edit a little bit so you can see the primary, secondary. But very similar setup overall to what we saw with the failover record as far as having two records that we're going to define. And we can have more than two records as well. So, but our different resources and stuff that we'll have in here. I just have the one IP. I don't have any health checks implemented, but we'd want to probably implement a health check so that if we didn't have a healthy resource, right, we could make sure that we had a healthy resource available so we're not routing your traffic to things that aren't healthy anymore. Same thing with the record ID set where I'm going to have a multi-value record ID, or just say have it record one for my record ID that's going to be unique. I could leave this off if I wanted to. It does say it's optional. Definitely recommend having one because you wouldn't want it to be, since it is essentially just kind of round robin through the different available services in the background for it, like the EC2 instances. If you didn't have a health check, there's an opportunity that it could send to your user traffic to it overall. So just wanted to make sure that we called that out and showed kind of a little bit here. But with these health checks in place and with your record configuration the same as you would have a failover, you'll be able to do a very similar thing as you have where you have multi-region architectures where you're going to have something in US East, US West, and be able to implement a multi-value answer there to get between the two of them. So just wanted to cover that real quickly and show that you have the same kind of availability to leverage with those multi-value answers that Ashwini was mentioning before to help you increase kind of the reliability. You could pair these with other types of records that Ashwini was mentioned before to have like your geo-proximity, so you can have things closer served up so you can improve performance. But we'll cover that today. And for now, I'm going to turn it back over to Ashwini to cover a little bit more on some of these advanced kind of combination of record types and such.
Before we move into a complex routing policy, I could like to quickly provide some insight about the evaluate target health. So it's an option when you create a alias resource record set that's very specific to Route 53. So customer could use the evaluate target health with AWS resources and with a multi-layer DNS architecture along with the routing policy. In a multi-layer DNS architecture, as long as there is one underlying path that's healthy, then the path itself is considered as healthy. So when you enable this evaluate target health for any of your alias resource record set, this causes Route 53 to determine whether there is any healthy resource within that branch before even trying to see and route traffic to another branch. If there is nothing which is healthy in one branch, then Route 53 have opportunity to choose the healthy resource in other branch. But that is possible only if you have this evaluate target health enabled in all of your branch. So we will quickly get started and look into some of the complex architectures. So with a geolocation routing policy, we can achieve high availability use case where we can implement a failover within the geolocation routing policy. In this scenario, for example.amazon.com, the first branch is the US region with a failover record set that's pointing to US East region ALB and US West region ALB. And additionally, we have four other like geolocation record created for North America, Asia, and default. So consider the user is trying to resolve the domain name that's example.amazon.com from Texas. Provided if both the primary and the secondary health check is in a healthy status, it will resolve to the primary record set. But if the primary record set is unhealthy, it obviously will go to the secondary record set. Like I want to give a quick insight about how does the geolocation works by default, like without any complex, like having a geo with a failover. How does it work? If a endpoint is unhealthy, the Route 53 will look for a record for a larger and associated geographical region. For example, suppose you have a United States record set, you have a North America record set, and you have a default record set. If the endpoint of United States record set is unhealthy, the Route 53 will check the record for North America, and it will also check for the record for default in that order until it finds a healthy record to resolve, like for the Route 53 resolve. If all the applicable records are unhealthy, consider everything is unhealthy, then Route 53 will resolve to a smallest geographical region, which is like a US region here. But here the scenario is different because we have a failover record in top of like failover on top of your geolocation record. So here, if the failover record, like both the primary and the secondary fails, by default Route 53 will result to your primary record. That's what Rob also mentioned in his demo, and we saw that in one of our architectural in previous slide. That is the actual behavior of failover. But if you want like your user to resolve to North America region, which is your larger geographical region, to do so you need to enable evaluate target health and for the geolocation branch as well as for your underlying branch, so that the Route 53 will branch out from the failover and it will resolve to your North America region. And as I mentioned, if both the US as well as the North America is unhealthy, the Route 53 will resolve to the default one, which is the like if you can have something like an S3 maintenance page there, and it will resolve to your default one. And moving forward with our next, here is a scenario of high availability available scenario using multiple routing policy. You can go to any level of combining routing policy in Route 53. So here we have two branches. First, let me give you some insight about the first branch, where with the primary branch, we have a geolocation routing policy for North America and then default, and both of it is like having a health check associated and ETH enabled. When the primary branch resources are healthy, the Route 53 will resolve to the geolocation record set if the status of the health check is healthy based on the location of your client. On the other side, we have this one, the secondary failover branch, where we have the latency routing policy with two regions, any region based on your use case. And on top of it, we have a weighted routing policy with weight 30 and weight 0. Weight 30 is pointing to your latency record set, alias record set, and the weight 0 is pointing to your S3 maintenance page. Let me. Okay. When a user is trying to resolve web.amazon.com, it will check if there is any resource which is healthy in primary branch based on your location. If I'm coming from anywhere from Texas or California, I'll be like, if the primary is healthy, then I'll be going to the North America region. But since the ETH is enabled in the primary branch, Route 53 will know if the whole branch becomes unhealthy, it needs to look for a healthy resource in your another branch. What does that actually mean is, when a client is trying to resolve it, consider your complete primary branch is unhealthy. The whole one is unhealthy. With the evaluate target enabled in the main domain name, it will check where the client is coming from and resolve the record with a less latent one, as the weight is 30 there compared to the weight 0, which is pointing to S3 bucket. If both the latency record set is unhealthy, the client will resolve to a S3 maintenance page. This is how you can go to any level of combining multiple routing policy to achieve your particular use case. And in next, I will be just discussing about one of the use case from a customer, where here's the architecture for highly available fault tolerance global web application. Customer could like to have like a multiple use case. Like here, the use cases, they want all the user that are located in China to reach their local web server, and all the customer from other countries go to a data center in a different region like Oregon, Ireland, or Tokyo based on the least latency. They are not combined with a geo kind of thing. Of course, if none of the data center is available or healthy, the customer could like to fail over to a static website which is running in S3 bucket, or it can be a different resource which is like providing the same resource like a replica of it to achieve a high availability. So based on all the architectures which we are discussing with, these are the sample architecture. So with Route 53, you can achieve high available and high reliable use case and combining multiple routing policies. And I'm handing over to Rob for talking about Route 53 application recovery controller.
Thanks, Ashwini. Appreciate all that additional information on kind of combining those different complex routing mechanisms. So we covered today how you can get kind of implemented in using, or how you should be using, right, Route 53 failover, multi-valued answers to help you increase resiliency. Once you've kind of adopted those and you started to get implemented into the different recovery strategies using Route 53, we wanted to kind of just quickly talk about the Route 53 application recovery controller. So our Route 53 application recovery controller is going to be kind of that next iteration to be able to help you be able to check health of both sites and to make these actual failover implementations happen for you. So you're going to be able to use Route 53 application recovery controller once you have these different implementations set up to monitor essentially the health of your two different environments and allow you to make implementation changes if you have to during a disaster event. So if you have something that happens in US East 1 and you have an infrastructure in US West 2, you could use the application recovery controller to actually move all of your resource target essentially over to your other region as well. So just wanted to make sure, we'll drop a link in, or Clint will drop a link into a little bit more on the application recovery controller, and we may talk about it more later on another episode, but definitely take a look at it. It's a nice additional way to help you implement these failover mechanisms. The key thing is to do these things ahead of time, right? Before you have an actual event happen, have these automated failover records in place that you don't have to worry about when something happens going in and making a manual change at that time. So that's probably the biggest thing overall. So Clint, just want to pull you in here to see if we have any questions from the audience. Otherwise, that's pretty much everything for today.
No, Rob and Ashwini, thanks for that awesome presentation today. We really appreciate it. There is no more questions that have come into the chat since the last time. So everyone, thanks for tuning in to AWS Supports You today. We looked at some features of Route 53 and how you can leverage the routing policies to increase reliability within your environment. I believe we did answer all of your questions. However, if there are other questions that come up on Route 53 CloudFront, we talked a little bit about, or any other AWS services, head over to repost.aws, where one of our experts can provide you with an answer to your question, or you could become a topic of one of our future episodes. So if you do have any other further questions, feel free to email us with your feedback also at awssupportsyou@amazon.com. We definitely want to hear from you so that you have a voice in the show, and tell us what you'd like to see or hear about. So next Monday on AWS Supports You, we will have another episode where we will cover getting started with exploratory data analysis on AWS. So we look forward to seeing you then. And thanks for joining us at AWS Supports You today, and happy cloud computing.
Happy cloud computing, everyone.